Hi there, this is Jacob Nash Calculus Lessons, and this is a video about trigonometry graphs. So, this is the first calculus video that I made. There are other ones. I've made geometry, engineering, algebra, and pre-calculus lessons also. And I'm not going to make any more after this until probably almost a year, because I'm just doing this first prerequisite one right now. So it might be a good thing to remember some pre-calculus things about trigonometry before you watch this, but here's what the graphs look like of the three ones, sine, cosine, tangent. So if you notice, sine and cosine look kind of alike, and then tangent looks kind of strange. But the thing that you have to know about these graphs is they're kind of different from the other ones that you've maybe learned before, because they don't have x and y points. Well, they technically do, but they call them angle and whatever of angle, like sine of angle, cosine of angle, tangent of angle, as you see with these tables. So it makes sense if you have an angle of 0, sine of 0 is 0. Sine of pi over 2, if you remember how to convert to radians, you just replace pi with a 180. 180 divided by 2 is 90, and sine of 90 is 1. And that's how you get those points. So I'm not going to go into a whole lot of detail right now, because there's a lot on here, but that's how you get these points. And so if you see sort of just like a wave for those, and then tangent is a little bit different. Why is it does not exist? Well, if you remember, tangent is x over y. And but anyways, if you have tangent of 90, that doesn't even exist. That's what it says. But if you remember from a unit circle, y, well, at 90, there's the point 0, 1 at pi over 2 or 90, and 0, 1, those are the points, and tangent is y over x, and the y point is 1 divided by 0, 1 divided by 0, can't do that. So that's why that doesn't exist. And so there's, anytime you have something divided by 2, the divided by 2s, they're sort of like coterminal angles in a way, and do not exist. And the pattern for the y points for the tangent one is -1, 0, 1 does not exist, and that's what it's like. The domain and range are the same for sine and cosine. Domain, all real numbers, range, -1 to 1. And then for it's kind of harder to say in word form for tangent, but it's basically any value that's doesn't have a denominator of 2. And then the range is all real numbers 2, because they go to negative infinity to positive infinity. And some helpful videos are Khan Academy, sorry, if you want to see that. Now, there's things called midline, amplitude, and period. And you might have even heard, you might somewhat know what these mean, like amplitude. Well, amp, like, doesn't that make you think of like sound waves? So that and the extent of the sound waves, up or down, if you know anything about like how sound is, that's what amplitude is. So this graph describes what they are. So the midline is just in between how high or low it goes. And in this case, it happens to be the x-axis, but it's not always like that. Amplitude is just how far it goes from the midline to the proper words are, well, I'll just say high and low points, but there's technically proper words for that. But the period is how long it takes for it to get to a part that's like that again. And that's kind of like vague language, but I don't exactly know how to put it in word form. But as you see, a full period is from where it's at this point, like halfway into the top, and then halfway to the top again, that's a period. So this would be another period right here. And 1/4 of a period, that's right there, half period, 3/4 period, that's how that works. And for any equation, this says cosine, but it could be sine too. A is the amplitude, and B is, well, 2 pi divided by B is the period. And notice it's absolute value. That's how you get those. So absolute value of whatever happens to be there for A, that's the amplitude, and then 2 pi over the absolute value of whatever's by the X, that's the period. And here's a Khan Academy example. If you were trying to find the amplitude and period. As you can see by this equation, the amplitude is 1/2. Even though it's 1/2, you have to take the absolute value. That's what you have to do. For the period, it's not just 3, it's 2 pi over 3. And the absolute value of 3, but that already is 3 anyways. And you can see how that would graph, but we're going to graph some in a minute. And if you have a negative, this is the same thing for amplitude. If you have a negative period or amplitude, it still will be positive. Like, I don't know how to explain it. Like, it will still be positive, but that there will be a reflection. So let's graph this. And I hope this doesn't freeze up, because sometimes it does when I try to draw on the computer. But we're trying to graph 2.73 sine of negative x. So we have two transformations. We have 2.73, and that happens to be the amplitude. So amplitude is 2.73. And then we have a negative right here, but the negative is really a -1. So the period would be 2 pi over -1. But you have to do the absolute value, so it's really just 2 pi. So anytime you give an amplitude or period, they're always going to be positive, but there still is going to be a reflection because of this negative. That's what I just said. So it's basically saying that the period, remember the period, when it gets back to the same point again, that will be at 2 pi. Each time it's 2 pi. And I don't know why I forgot the negatives here. Sorry. These are negative. And so if you notice, they're the x and y points, but technically the angle and the sine of the angle points too. So here's how we do this. We have to think, if you have, we're going to just go to each x value and figure out what the y value would be. So sine of pi over 2, that means sine of 90. Type that in calculator, that's 1. But since our amplitude is 2.73, we actually have to make it 2.73 instead. So it'd be right here. So that's what the transformations do. Then sine of pi, so sine of 180, happens to be 0. Well, happens to be 0, it is 0. And so we have 0, but once again, we have a different amplitude than that. So well, if you look up at this example here, that the amplitude, even though it would go to 0. Oh, wait. Oh, okay, sorry. I don't know what I was thinking. It still is 0. Sorry. That doesn't change for that part. Sorry to confuse you. That's for the next one. So 3 times 180 divided by 2 is 270. Sine of 270 is -1, but instead of -1, we do -2.73. Sorry, got that mixed up for a second. Sorry. And then 2 pi, that's going to be 0 again. Now we go over to the negative side. This would be 0. So you would probably start to see a pattern. Just basically 0, something, 2.73, negative or positive. And that's how it would be. And the period is 2 pi. And if we connect these dots to show our graph, oops. Not a very good graph, sorry. and it would technically would go on, so I'll just put an arrow. All right, that is what it would be like. And if you notice, here's a certain point, 2 pi later, is that it like the same thing again? Yes, so that means we did the period right. And, but if you remember, the period was negative. So that actually means something a little bit different. That would be if it was a positive x. Now we have to make it negative. So instead, we are going to have a reflection over the y-axis. Yes. So a reflection over the y-axis is, that would make, I think, oh, I'm sorry, I'm a little bit sick today, that's why. Well, a reflection over the y-axis. If we were to graph this into the calculator, if we were to graph this into the calculator, so there needs to be a reflection, but for the sake of this example, let's just take away that negative, because we are going to look at an example where we have to do a reflection anyways. So, but just keep in mind that would mean a reflection. All right. Now this one. The amplitude is the absolute value of what you see before the cosine or sine, and that means 1.06. Then the period would be 1/2, or not 1/2, sorry, 2 pi over 1/2. And if you know, that actually means times times, this thing's not doing undo when I do Control Z. And that would just mean 4 pi. You multiply that. Okay, so that means this graph is pretty much scaled wrong, but let's just pretend this is 4 pi. All right, so same process pretty much, except we're gonna have the endpoints here. And so our amplitude goes to 1.606. So the cosine of 90 is 0. So it's going to be here, 0, 0, 0, 0. And we're just not going to focus on the negative part, but just know that it would be the same for the negative. And then cosine of 180 is negative 1. But we have to make that negative 1.06. But instead, since it's 4 pi, it's actually, things are going to stretch out sort of horizontally. So instead, it's a little bit hard to explain like verbally, but the points were going to be at pi and 2 pi, there was going to be 4 points, but now there's only 2 because it stretches out. And so then there would be a 0 point here and a 0 point here. So it would be like this. Oops. That would be positive up there. And that's what it'd be like. And it would do the same thing over here as well. Okay, and that is how you would graph that. If you notice, does it take 4 pi to get back to the same place that it was at? Yes. And then the midline, anytime you have midline, it's the plus or minus whatever it is. If that happened to be a -2, then the midline would be y equals -2, but it's always an equation. So that was not, this was not a very descriptive video, but it's sort of a review of these graphs. So thanks for watching this video. Sorry that there was a little bit confusing parts and I had to take out some things for time's sake, but that is what this video is like. And yeah, I forgot that there was a reflection here as well. But I'm going to do the same thing and just we will ignore it. Because not that it's not important, but that's not what I had time to discuss in this video. But thank you for watching, and that'll be it.